to you by Thesis123.com. I learn and teach online.
Here is the 8th question. Consider a continuous time system with input x of t, output y of t, given by y of t is equal to x of t times cos of t. So we have our 4 options saying that this system defined by this equation or defined by the output given is linear and time invariant, non-linear and time invariant, linear and time varying, and non-linear and time varying. So basically we have 2 aspects to work here. We have to check the linearity of the system given, and we have to find a check on the time invariance of the system given. Okay, so those are the 2 factors. The first is linearity and the second is time invariance. Okay, so there are 2 conditions to say that the system is linear. One condition is that it must be homogeneous, and the second is that it has to satisfy the additive property. So let's work on linearity first. Okay, linearity property. The function given to us is y of t is equal to x of t cos t. So in order to see if this equation is additive, let's take 2 conditions. Now the first one, y1 of t, let's assume 2 different variables. y1 of t is equal to x1t cos t, and the second is y2 of t is equal to x2 of t cos t. x1 of t corresponds to y1 of t, x2 of t corresponds to y2 of t. Now if we add both of these, let's see what we get. So we add the left hand side, y1 of t plus y2 of t, that would give us x1 of t cos t plus x2 of t cos t. We can take cos t common, x1 of t plus x2 of t into cos t. Okay, now let's assume that x1 of t and x2 of t, the addition of both is x of t. Okay, so let me write that down over here. Let x1 of t plus x2 of t equals x of t. So let's plug that in. So we have y1 of t plus y2 of t is equal to x of t into cos t. This is x of t times cos t. But what is x of t times cos t? That is the very function that is given to us in the question, y of t. So we substitute this over here and we will obtain y1 of t plus y2 of t is equal to y of t. So if we add 2 possibilities, y1 of t and y2 of t, we obtain the original y of t. So this satisfies the additive property and therefore the given system is linear. The system is linear. Now let's check on time invariance. Let me just take another sheet of paper. Okay, just so you know, now because it is linear, that removes 2 of the options here. So we are left with either A or C. So we have to see if the given equation or the given system is time invariant or time varying. So basically, if the system has been given a certain delay in time, a delay in the input signal, so we have to check if it still changes as an entire function or it doesn't change. So we have to check on that. Either it changes or it doesn't change. So that's time invariance. Okay. So let's consider y1 of t is equal to x1 of t times cos t. Now if, let's take this part here, if the input, if x1 of t is x times t minus tau. Now here this tau is the delay in input signal. Delay in input signal. So we are giving a certain delay to the function, to the input. So x1 of t is equal to x times t minus tau. Now let's substitute this in place of x1 of t, and let's see what the equation becomes. y1 of t, the output becomes x times t minus tau cos t. Let's call this equation 1. Now, so this delay, let's apply this delay to the function given to us in the question, the original equation. Okay, the original equation says y of t is equal to x of t cos t. Okay, in place of t, wherever t is there in this equation, let's plug in t minus tau. So we are applying the delay in the entire equation. So that's y of t minus tau is equal to x t minus tau cos t minus tau. So in the original equation where t is there, we plug in the delay t minus tau here, here and here, and we get this second equation. Now observe the first equation, the second equation. Are they same? They aren't. y1 of t is not equal to yt minus tau because the delay here is applied only to the input signal and it doesn't correspond to the entire equation, but here it corresponds to the entire equation, the input and the output. So we see that y of t here, y1 of t is not equal to yt minus tau. So when we give the delay, it is not equal to the equation given to us, the function given to us. So that means that it is a varying system, a time varying system. Time invariant is when both are the same. So this is time varying. Now let's check. It is linear and it is varying. So that's option C. So here is the final answer. I hope it has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.